1, 2, 3, 1, 2, 3. Hello guys, welcome to another video. Today we're gonna look at another LeetCode problem, flip equivalent binary trees. I picked this one because it's recently asked by Google and it's a medium question. Not gonna bang on my head too hard, I think. So let's get started. For a binary tree T, we can define a flip operation as follows. Choose any node and swap the left and right child subtrees. Okay. A binary tree acts as flip equivalent to a binary. Well, this is typical Google thing, right? This very characteristic googly question. They kind of invent or introduce a lot of new ideas or definitions for you to work on to a binary tree y if and only if we can make x equal to y after some number of flip operations. Okay. Write a function that determines whether two binary trees are flip equivalent and the trees are given by root nodes. Okay. Root 1, root 2, and here's an example. Here we see 2 and 3 got a flip, and this 7 and 8 is also flipped. Cool. So each tree, well, the node here, well, sometimes it contains some useful information. So each tree will have at most 100 nodes. It's good to know. But sometimes, like at most 100 nodes. 100 is not a very big number. Sometimes we can use like a count sort kind of thing, you know. But let's see if that's kind of useful for this question. Each value in each tree will be a unique integer, so that will be a very important thing. So the value in the root of a subtree can actually work as a key or identifier. You name it, like whatever you call it. I mean, it's a unique identifier for the subtree. So it should be easy, right? And I'm thinking about using recursion here to make things readable and read less. So if root 1 is 9, and root 2 is 9, return true. That should be the easiest case. And well, I should say probably we can have something more clever. And if, damn it. Turned out not so clever, right? Not so clever. Well, I really want to cut it out, but I'm not going to edit it, as usual. Well, sometimes your brain wanders to another realm without you even notice it. Root 1 is not. Okay, that should do the trick. And if they are both non-return true, and if only one of them, if and only if, one and only one of them is none, and the other is not, return false. Okay, now we can assume that both root 1 and root 2 are not empty trees. So we can say v1 equals to root 1 dot val, and v2 equals root 2 dot val. Right, and if oopsie, what am I doing? Right. Ha. Whatever. Let's say node 1 is from tree 1 and node 2 is from tree 2. So for now, initialize them as the root nodes and then do the recursion. Right. Wait a second. If I'm doing recursion, I don't need to do the loop, though. Well, anyways, I'm going to undo all the changes. Okay, here. So if v1, there's a mismatch, return false right away. And else, if they are of the same value, then we'll need to get the keys of the 4 subtrees, right? So it's going to be left 1, right 1, left 2, right 2 equals to root 1 dot left, root 1 dot right, and copy paste and change the number. So now let's check the values, right? If here's the catch. How can we do it all together, right? If left, okay, if flip equivalent self, do I need to pass the self here? Anyways, let's just do it anyways, and probably not. Well, okay. Let's give it a try then. Self dot flip equivalent left one with 2 and R1, R2. So this is like unflipped at this level, or it's going to be a long line of code, right? So left one, wait a second. Yes, R2 and R1 left 2. Exactly. So this is a kind of a flip. Then I would say return true. Okay, and else, otherwise return false. Well, it's kind of weird that I forget if I should pass the self here or here, but let's run the code and see what's happening. Okay, we got the result we want for the example test case, and for a second test case, I probably want a deeper level, right? So 8. The way they do it is pre-order traversal. So it's better to just append it at the very end if I want some extra values. I hope so. So for 7, I add 1, 9 in the null. I think this should do it, right? An extra value. And also we want a mismatch, something like this. Run the code. And we got a pass on our own local tests. Wow. Oh, wow. And this is the first time I see beating 100%. Probably no one's writing it in Python, perhaps. Let me check. Well, a couple of people here. A couple of submissions. I'm on the top. Oh yeah. What are the other guys doing? Huh? They're over-engineering. They are over-engineering. Duh. Okay. Never mind. So this is gonna be the end of the video. Let's go back to the question and give it a final look. It's quite straightforward, right? So first of all, this is a pre-order. The input is kind of a pre-order, but we don't have to think too much of it because we're not gonna handle the input. We're not gonna parse the input. The input is already parsed for us, and so a bit of a trick here. Just use recursion, right? Don't over-engineer. Don't think too much on this step. So if unflipped is a mismatch, is matched. If at this level it's not flipped and it's equivalent, it works, or it's flipped and it's equivalent. And here I'm not actually going too deep because the value here, well, the runtime, if we don't have the constraint here, let's say saying the unique integer, this may not be the optimum solution, I think, because it's wasting a lot of runtime to go deeper on until they find it's not the same shape, right? It's gonna depend on these criteria, this constraint is saying they're of the same shape. But it kinds of every mismatch or the unequivalency is discovered during, like most of them are discovered by this step, by this constraint, saying that their key doesn't match, and there's an instant return on that without going any deeper. What I'm thinking, if we don't have the unique integer, this could be a follow-up question. Like we don't have this constraint saying the values are unique, then, well, it's better off to, let's say, store the value of the size, either the size, like try to reuse the shape of the tree instead of doing it every time, maybe. So like flip and unflipped. It could be just avoiding a lot of trouble here, but no guarantees. It could cut the runtime short on average. But yeah, that's it for this question. I'm kind of surprised that I just beat 100 out of 100%. In both memory and runtime. Cool. I'm happy. I'm a happy man. Bye-bye.